Hello and welcome to the second Tech Talk online from Blum-Novotest GmbH. My name is Dominic Mertz and I currently work in OEM sales at Blum. In this video, I want to introduce the concept of machine-integrated tool measurement using laser measuring systems by Blum. Especially in highly automated and interlinked systems, they help to provide lasting improvements in productivity and in process reliability. To give you an overview of today's Tech Talk online, I will begin by outlining the agenda. In the first point, I want to present the tool measurement possibilities. I will then introduce the components of the LC50-DIGILOG system. These include hardware as well as software features. I then want to examine the functional scope of the devices in greater detail and introduce the measuring cycles using our specially developed app called MeasureXpert. I would like to conclude today's Tech Talk online with some application examples along with a brief description and examination of our new visualization and evaluation software LC Vision. As I stated, I would like to start by providing an overview of the possible tool measurement variants. In this case, we distinguish between tactile and optical systems. Here on the left, you can see our Z Nano tool probe for tactile tool measurement. The other two components are optical tool measurement systems. Here, we draw a distinction between laser measuring systems such as our LC50-DIGILOG and the other optical tool measurement systems, the presetters. Naturally, each of the devices shown here has a specific purpose. However, the advantages of laser measuring systems are obvious. For instance, you can use them to perform machine-integrated run-out monitoring of tools as well as to record corresponding tool change errors, dynamic spindle drift or thermal machine drift. Other key advantages of laser measuring systems are their ability to identify tools and the related possibility of single cutting-edge monitoring. Many people struggle to believe that optical systems can withstand the harsh operating conditions in machine tools. In this case, however, Blum devices benefit from decades of experience where the primary focus has always been on maximizing in-process reliability. In the following video, you will see a typical tool measurement or tool check performed under the harsh conditions of a machine tool. Fast, precise, reliable. This is how we describe the functions of our LC50-DIGILOG. I now want to present the hardware and software features that underpin these three key words. I will begin with the pollution protector, which protects the laser optics against contamination. In the most recent LC50-DIGILOG laser generation, this pollution protector can easily be mounted or removed without the need for additional tools. As already mentioned, the pollution protector hides the laser optics of the system. These have been perfected for the LC50-DIGILOG based on decades of experience and now have an extremely round beam shape, which makes it even easier for us to measure the smallest tools. Furthermore, a nozzle is already installed on the LC50-DIGILOG support device, guaranteeing that tools are 100% clean. I will wrap up the hardware overview with our smart dock. I always like to compare the smart dock in the LC50-DIGILOG with an intelligent docking station for a smartphone. For example, inside the smart dock are pneumatic valves that open the pollution protectors to allow the transmitter and receiver to communicate with one another. These valves also activate the nozzle. The DIGILOG name refers to the important innovations in the software range. The name DIGILOG is a combination of digital and analog and is used to describe how we generate the measurements using the new systems. In comparison to previous systems based on the generation of digital measurements, DIGILOG technology allows us to record and process not only single data records, but thousands of measurements per second. This brings us back to our three key words mentioned at the outset: fast, precise, reliable. When using Blum measuring cycles, we make a distinction between calibration, measurement and verification. To ensure optimum in-process reliability and precision when it comes to tool measurement, we recommend that our customers calibrate their laser measuring systems regularly. The tool measuring processes shown here involve taking length and radius measurements, for example, of ball nose mills or end mills. The term verification means carrying out a quick check on the tools, such as breakage detection or single cutting edge monitoring. To generate the right cycle call quickly, our programmers developed an app. The Measure Expert app is available free of charge from all current app stores. It is also available as a desktop version. In 5 steps, you can access the correct cycle call. In this case, I choose the hide and hen control. I select a drill as a tool, and I want to check it for breakage. I specify a breakage tolerance and immediately receive my cycle call, which I can then transmit directly to the control. Naturally, different industries have different requirements. In the area of medical technology, for instance, we help customers who are measuring or monitoring conical thread mills. We support the verification of roughing tools in the automotive industry, or the measurement of forming cutters or ball nose mills in tool making and mold making companies. As you will see from the following video, even the small, compact machines used in the jewelry industry must cope with harsh ambient conditions. The LC50-DIGILOG is also ideal for performing measurements where very high in-process reliability is required. As you can see in this video, very small tools are measured here to enable the component, in this case, a wedding ring, to be machined with in-process reliability. I want to show you how you can benefit from using the LC50-DIGILOG based on a simple breakage detection example. Without breakage detection, breakage of the core hole drill is not detected and the follow-on tool, in this case a tap, suffers a collision. The tool is destroyed, the workpiece damaged or, at worst, scrapped, and the machine is at risk of failure. If you had performed this step with integrated breakage detection, the laser measuring system would have detected the breakage, the tool or workpiece could have been replaced and the thread would have been drilled. In this case, we would have avoided a machine shutdown, a damaged follow-on workpiece, and saved the costs of destroyed follow-on tools. I would like to conclude today's Tech Talk Online with a short preview. At the recent EMO trade fair, we presented a new software solution named LC Vision. LC Vision is an innovative evaluation and visualization software program for Digilog laser measuring systems from Blum. The software uses the generated measured values to perform a quick optical analysis of the quality of the tool and the motor spindle. The stars of the show here are the intelligent analysis methods for enhancing the quality of machining. For example, if the laser measuring system detects wear, you can then generate application-specific data directly to correct the tool parameters, which can then be automatically included in the cutting process. In conclusion, I would like to thank you for your attention, and I hope that you found this presentation interesting. We look forward to your participation in the next Tech Talk Online and would be delighted to answer any questions you may have. You can find our contact details in the video description below. Stay safe and goodbye for now.